Hello, everyone. Hope you are doing well. Today, I'm gonna talk about the different fusion technique, which are leveraged in order to tackle the complexity of the multimodalities. As you follow my videos, in the previous video, I was talking about the data modality in the healthcare. In that video, we were talking about the images, text, time series, tabular data, video, and that sort of data modalities. Today, I'm gonna talk about the different fusion technique. We know that the fusion technique is employed to mix and blend the information from the different sources and different modality and types. We have at least four well-known fusion techniques. First one is named LE fusion, combining raw data from the different modality. Second one is the intermediate fusion, embedding a space transformation. Third one, late fusion, combining prediction from the separate models. And the mix fusion, mix of the fusion techniques. I think it would be very interesting. Let's dive deep into the LE fusion. I would like to inform you that it's the simplest in terms of the implementation and in terms of the complexity. LE fusion is the simplest one approach. Some people called it data level fusion. Others called level fusion. You can see in here in this diagram, we have at least two different modality. One different, the blue refers to the one modality, supposing that text, and the yellow refers to the another modality, for example, image. We need here a feature extractor model. Extract the feature from the text, extract the feature from the image. Okay, the output is the real value vector, embedding vector. Extracted from the text here, the yellow one extracted from the image. Okay, we need aggregation. We need to aggregate to the embedding vector here. We have there are lots of well-known aggregation method. For example, we can simply add concatenation or average two vectors, or we can use a attention layer or fully connected neural network here in order to aggregate two vectors. Both vector finally, after aggregation, finally unified in the one real value embedding vector and is fed to the machine learning model. The loss function produced in the output could be used for computing the gradient and new weights for the ML language model. Commonly used model in this technique, CNN mostly used in for image analysis, and XGBoost mostly used for a time series data. Advantages of the LE fusion: preserve original information for each modality. Of course, we have a model feature extractor for each of modality, but holding and keep the necessary information in the real vector produced as output of the um, feature extractor. Simplify model architecture by merging the data before learning and reduce computational complexity in some cases. Challenges of the LLM fusion: data richness imbalance, future incompatibility, and inflexibility. Of course, some modality requires more processing. For example, text versus image. Of course, image needs the sophisticated method in order to analyze the data. Feature incompatibility. Low-level features could be different from the in each modality. For example, in the text we just use a simple method of word embedding, but in the image we have to use the image edges. We have to extract the edge of the object. Inflexibility. Adding a new modality may require the retraining the entire the model. Some examples in cardiology, XBox for integrating lab result, demographics, vital signs, and the image feature for the cardiology predictions. On oncology, fusion of the CT scan and PET scans with the demographic data in order to detect the lung cancer disease. In neurology, MRI and PET fusion for Alzheimer detection. This is a very good example of this early fusion.